In the age of artificial intelligence and autonomous machines, humanity stands at the threshold of a new industrial revolution driven not by the sweat of labor, but by the silent precision of code and circuitry. The idea that machines could think, move, and even feel in a human-like way has long captivated the imagination of scientists, engineers, and dreamers alike. Yet when the world speaks of robotics, when it celebrates the achievements of inventors like Nikola Tesla, Isaac Asimov, or even Leonardo da Vinci, it often forgets the name of one man whose ideas laid the foundation for what we now call modern robotics. He was a black man, a mechanical prodigy born into a world that sought to erase his brilliance, and his name was Elijah McCoy. Though history remembers him faintly as the real McCoy, his true legacy extends far beyond the steam engines of the 19th century because his innovations created the mechanical blueprint for automation itself, the essence of modern robotics. To understand McCoy's place in the genesis of robotics, one must first step back into the world that shaped him, a world of racial violence, technological upheaval, and the quiet determination of a man who refused to let his genius be contained by the color of his skin. Born in 1844 in Colchester, Ontario, Elijah McCoy was the son of George and Mildred McCoy, African Americans who had fled enslavement in Kentucky through the Underground Railroad, traveling hundreds of miles through forests, across rivers, and past slave catchers who would have killed them for attempting escape. Canada was a refuge for thousands of fugitives escaping the brutality of bondage, and the Mesquite family found safety in the northern lands that promised freedom, but safety did not equate to equality. Black families, even in Canada, faced racial barriers that made education and opportunity scarce, with many communities refusing to allow black children into schools and employers turning away qualified workers simply because of their race. Despite these obstacles, young Elijah displayed a remarkable talent for understanding machines and how they worked, spending hours disassembling pocket watches, studying the movement of water wheels, and sketching designs for mechanical devices that existed only in his imagination. His parents, recognizing his gift, scraped together their savings and sent him to Scotland at the age of 15 to study mechanical engineering, an extraordinary act of sacrifice for a formerly enslaved family in the mid-1800s. The decision came at great personal cost because sending Elijah abroad meant the family would be separated for years. But George McCoy, who had escaped slavery with nothing but the clothes on his back, understood that education was the only weapon that could not be taken away by racist laws or violent mobs. In Scotland, McCoy received a rigorous education in mechanical and railway engineering at the University of Edinburgh, one of the most advanced engineering schools in the world at the time. This was no small feat because very few black men in the 19th century received formal education in such disciplines, and even fewer were accepted into European institutions that prided themselves on academic excellence to people of African descent. McCoy studied under some of the leading engineers of the era, learning the mechanics of motion, thermodynamics, fluid dynamics, and the art of precision design, skills that would later help him reimagine the automation of machinery itself. His professors recognized his extraordinary aptitude for solving problems that stumped his peers, and several of them privately encouraged him to continue his studies and pursue advanced degrees. But McCoy knew that returning to North America with a doctorate would not change the fact that the world saw his skin color before it saw his credentials. He spent 5 years in Edinburgh, absorbing everything he could about the emerging field of mechanical engineering, studying the works of James Watt, whose steam engine had revolutionized industry, and reading the writings of Charles Babbage, who was beginning to envision machines that could perform calculations without human intervention. When McCoy returned to North America in 1865, however, he found that the world was not ready to accept a black engineer, and the optimism he had carried with him from Scotland evaporated within weeks of arriving in the United States. The Civil War had just ended, slavery had been abolished, but the social and economic structures that had sustained white supremacy remained firmly in place. And in the North, where McCoy hoped to find work as a mechanical engineer, employers simply refused to hire him. Despite his international credentials, despite his mastery of engineering principles that most American-trained engineers had never encountered, the only job he could obtain was as a fireman and oilman for the Michigan Central Railroad in Detroit, a position that required him to shovel coal into furnaces and manually lubricate the moving parts of locomotives. It was a humiliating assignment for someone of his education and skill, but McCoy approached the work with the same intellectual curiosity he had brought to his studies in Scotland, and it was in that position, standing beside the roaring heat of steam locomotives, breathing in coal dust and oil fumes, that McCoy witnessed firsthand the inefficiencies of the industrial age. Steam engines required constant lubrication to function because the intense heat and friction generated by moving metal parts would cause machines to seize up and fail if they were not regularly oiled. And this meant that workers had to halt operations every few hours to manually apply lubricant to gears, pistons, and bearings, a process that wasted time, reduced productivity, and created dangerous conditions as workers climbed onto moving machinery to reach the parts that needed oiling. This laborious task sparked an idea in McCoy's mind, an idea that would consume his thoughts for years and eventually lead to an invention that changed the course of industrial history. He began sketching designs for a mechanical system that could automatically lubricate the moving parts of a machine while it was still running, eliminating the need for manual intervention and allowing engines to operate continuously without interruption. The challenge was immense because the lubricant had to be distributed evenly, it had to be released at the right intervals, and it had to be controlled by the machine itself rather than by human hands, which meant the device needed to sense when lubrication was needed and respond accordingly. In 1872, after years of experimentation in a makeshift workshop he had built in the back of his modest home, McCoy invented the automatic lubricating cup, a self-regulating device that distributed oil evenly across machinery without human intervention. The device worked by using the steam pressure and heat from the engine itself to regulate the flow of oil through a series of chambers and valves, creating a mechanical feedback loop where the machine's own operation controlled the lubrication process. It may seem simple today, but this invention revolutionized industrial operations in ways that contemporaries struggle to fully comprehend because trains could now run longer and more efficiently. Factories could maintain continuous production without stopping machines for manual maintenance, and the entire concept of how machines interacted with their own systems fundamentally changed. This automation of mechanical motion became a critical principle in the design of modern robotics, establishing the notion that machines could self-regulate, adapt, and sustain themselves without constant human oversight. McCoy's device was the first instance of a mechanical feedback system, a principle that lies at the core of robotics today, and while the engineers and industrialists who adopted his invention understood its practical benefits, few of them grasped the philosophical revolution embedded in McCoy's design. He had created a machine that could think, not in the sense of consciousness or awareness, but in the sense that it could respond to its own conditions and adjust its behavior accordingly, and that concept would quietly shape the next 2 centuries of mechanical innovation. In robotics, feedback is what allows a robot to sense, adjust, and correct its behavior in real time. Whether it is an autonomous robot arm adjusting pressure when gripping a fragile object, a self-driving car altering its path to avoid an obstacle, or a surgical robot making micro-adjustments during a delicate procedure, the concept is the same as what McCoy pioneered with his lubricator, which was in essence the first industrial application of mechanical autonomy because it allowed machines to perform self-maintenance without human interference. And that concept of machines maintaining themselves was revolutionary in the 19th century, and it would become the foundation upon which the entire field of robotics would eventually be built. The success of McCoy's invention spread rapidly across North America and Europe as railroad companies, shipping lines, and factory owners realized that his automatic lubricator could save them thousands of dollars in downtime and maintenance costs. His lubricators were installed in locomotives, steamships, factory equipment, mining machinery, and even agricultural devices, and they became synonymous with quality and reliability to the point where engineers and railroad operators would insist that they wanted the real McCoy, not an imitation, a phrase that would later enter common language as a symbol of authenticity and excellence. Yet, the man behind the phrase remained largely unknown outside of industrial circles, and even within those circles, his contributions were often credited to the companies that employed him or to white engineers who had purchased his patents. White-owned companies profited immensely from his inventions, and McCoy was often denied full credit or financial reward for his work because the racial hierarchies of the fund. Industrial era made it nearly impossible for a black inventor to gain recognition or control over his own patents. Many of his devices were patented under the names of his employers through contractual arrangements that gave McCoy a small royalty, while the companies retained ownership and profited from mass production, and others were outright stolen by competitors who reverse-engineered his designs and filed their own patents before McCoy could secure legal protection. Still, McCoy continued to innovate relentlessly, driven by a vision of a world where machines could free human beings from dangerous and repetitive labor, and over his lifetime he registered more than 50 patents, many of which laid the groundwork for automatic control systems, fluid mechanics, and the basic logic of mechanical automation, all of which underpin the science of robotics today. Each patent represented not just a technical achievement, but a political act, because every time McCoy's name appeared on an official patent document, it challenged the prevailing assumption that black people were intellectually inferior and incapable of contributing to technological progress. But McCoy's influence did not stop with the lubricating cup, and as his reputation grew within industrial circles, despite the systemic efforts to erase his contributions, he continued developing innovations that pushed the boundaries of what machines could do. In 1916, he invented a graphite lubricator that combined oil and graphite to reduce friction in high-temperature engines, a principle later used in aerospace and automotive engineering. And this invention demonstrated his understanding of materials science and thermodynamics at a level that few engineers of his era had achieved. He also developed devices for lawn sprinklers that used water pressure to regulate distribution patterns, ironing machines that could maintain consistent heat without manual adjustment, and even folding tables that used spring-loaded mechanisms to collapse and expand with minimal effort. Each of these inventions displayed a deep understanding of mechanical motion and energy efficiency. But what distinguished McCoy's genius was not simply his ability to create useful machines. It was his capacity to make them intelligent, to make them function seamlessly with minimal human input. And this philosophy of automation, of designing systems that could operate independently and intelligently, would become the defining feature of robotics as the field developed in the 20th century. McCoy understood something that most of his contemporaries did not grasp, which was that the future of industry lay not in making machines stronger or faster, but in making them smarter, capable of sensing their environment and responding to changes without waiting for human commands. To understand the continuity between McCoy's 19th century machines and modern robotics, one must look at the evolution of control systems and how engineers gradually moved from simple mechanical devices to complex automated systems. In 1948, nearly 80 years after McCoy's first automatic lubricator, Norbert Wiener published Cybernetics, or Control and Communication in the Animal and the Machine, a book that laid the theoretical foundation for robotics, computer science, and artificial intelligence. Wiener described feedback loops as systems that use sensory information to regulate their own behavior, and he drew parallels between biological organisms that adapt to their environment and machines that could be designed to do the same. What few people realize is that McCoy's lubricator functioned on the same principle decades before Wiener formalized the theory, because it was a closed-loop system where the movement of the engine triggered the release of oil, which in turn maintained the system's function, creating a self-regulating cycle that operated without external intervention. This was mechanical cybernetics long before the term existed, and McCoy's work bridged the gap between the industrial machine and the intelligent machine, a bridge that would later support the entire field of robotics as engineers began designing systems that could sense, process information, and act autonomously. By the early 1900s, as industry moved toward greater automation, McCoy's concepts began to echo through every factory and workshop in the industrialized world, and the assembly lines pioneered by Henry Ford in Detroit, the same city where McCoy worked for decades, were possible largely because machinery had become self-lubricating and capable of extended operation. The philosophy of machine autonomy had taken root in manufacturing, and Ford's famous assembly line, which revolutionized production by breaking complex tasks into simple, repeatable steps, performed by specialized machines, relied fundamentally on the principle that machines could operate continuously without constant human maintenance, a principle that McCoy had established with his automatic lubricator. Later developments in robotics, from the mechanical arms of General Motors in the 1960s to today's AI-driven robots in Tesla's factories, all rely on the same foundational logics McCoy introduced, which is feedback, efficiency, and independence. Every robot that self-corrects or self-maintains, every autonomous system that adjusts its behavior based on sensor data, every machine that can operate for hours or days without human intervention owes a conceptual debt to that first automatic lubricator built by a black engineer who refused to accept the limitations of his time and who imagined a future where machines could take care of themselves. McCoy's story is also a story of invisibility and systematic erasure, because despite his extraordinary achievements, his name never appeared in most engineering textbooks or histories of innovation published during his lifetime or for decades after his death. The systemic racism of the 19th and early 20th centuries relegated many black inventors to the margins of history, and McCoy was far from alone in facing this injustice. Granville Woods, often called the Black Edison, faced similar struggles for recognition despite his immense contributions to telecommunication and railway automation, inventing the multiplex telegraph that allowed communication between moving trains and developing dozens of electrical devices that became industry standards. Lewis Latimer, who worked with both Alexander Graham Bell and Thomas Edison, made critical improvements to the light bulb and drafted the patents for Bell's telephone. Yet his contributions were often attributed to his white employers or simply forgotten. Jan Matzeliger revolutionized the shoe industry with his lasting machine that automated shoe production, but died in poverty, while the companies using his invention made millions. These men, like McCoy, represented a generation of black innovators who laid the groundwork for technologies that define the modern world, but whose legacies were buried under racial prejudice and historical neglect that continues to shape how we understand the history of innovation. Even today, most people who use the phrase "the real McCoy" have no idea it honors a black inventor who revolutionized industry. And this erasure is not accidental, but the result of deliberate choices made by historians, educators, and institutions that decided whose stories deserved to be told and whose could be safely forgotten. In his later years, McCoy's health and fortune declined despite the fact that his inventions continued generating profits for the companies that used them, and he never received the financial security or recognition that his contributions merited. In 1920, McCoy and his wife were involved in a tragic automobile accident that left them both seriously injured, and his wife died from her injuries while McCoy suffered physical and emotional trauma from which he never fully recovered. The accident shattered what little financial stability he had managed to build, and he spent his final years struggling with medical bills and the grief of losing his partner. He died in relative obscurity in 1929, just before the Great Depression, at the age of 85, in a mental health facility in Eloise, Michigan, where he had been admitted after his physical and mental health deteriorated to the point where he could no longer care for himself. Yet even as his body failed and his mind struggled with the trauma of loss and the indignity of poverty, his inventions continued to hum in factories and railways across the world, self-sustaining just as he had designed them to be, silent testaments to the mind of a man who had imagined mechanical life before anyone called it robotics. His machines kept running, distributing oil with perfect precision, maintaining engines that powered trains across continents, ships across oceans, and factories that produced everything from textiles to automobiles. And in that sense, McCoy achieved a kind of immortality that transcends recognition or fame because his ideas became embedded in the infrastructure of modernity itself. It is important to understand that McCoy's legacy is not just technological, but philosophical, because he imagined a world where machines could relieve human beings of repetitive labor, where human intelligence could be extended through mechanical systems, and where the relationship between people and technology could be one of partnership rather than domination. This idea would later evolve into artificial intelligence and the dream of creating machines that think and act autonomously, pursuing goals and solving problems without constant human supervision. When we see humanoid robots performing surgeries with precision that surpasses human hands, drones navigating autonomously through complex environments, or industrial robots assembling cars with flawless consistency, we are witnessing the living evolution of McCoy's dream. And his idea that machinery could sustain itself and function with intelligence was not merely an engineering breakthrough, but a redefinition of humanity's relationship with technology. He envisioned a partnership between man and machine, one in which automation could enhance human life rather than replace it, freeing people from dangerous and monotonous work so they could pursue more meaningful endeavors. Modern roboticists often trace their lineage to the 1950s, when George Devol and Joseph Engelberger developed Animate, the first industrial robot arm that could be programmed to perform repetitive tasks. But beneath the layers of circuits, sensors, and computer code that power today's robots lies the same mechanical wisdom that McCoy pioneered more than a century earlier. His understanding that machines could be designed to act with purpose, precision, and persistence, that they could monitor their own conditions and respond intelligently to changes, laid the conceptual groundwork for everything that followed. Without McCoy's early insight into autonomous mechanical systems, the very concept of self-sustaining robotics might have developed far later, delaying the automation revolution that transformed manufacturing, transportation, and countless other industries. He was, in every sense, the original robotic engineer, even if he never used that term, and even if the full implications of his work would not be realized until long after his death. Today, more than a century after his death, Elijah McCoy's influence has spread far beyond the railways and factories of his time, reaching into research laboratories developing the next generation of autonomous systems, corporate boardrooms deciding which technologies to invest in, and classrooms where students learn the principles of feedback control and automation. Robotics companies, automation engineers, and artificial intelligence researchers continue to build upon the mechanical logic he discovered, often without knowing his name or understanding the historical roots of the concepts they take for granted. His story reminds us that the foundations of modern technology are not solely European or white, that they are global and deeply intertwined with the brilliance of minds that history once tried to erase, and that innovation knows no color. The spark of creativity and intelligence that drives human progress belongs to all of humanity, and the next time you see a robot arm moving with precision on an assembly line, or an AI system making calculations faster than any human could, or a self-driving car navigating through traffic, remember the black genius who first dreamed of a world where machines could think for themselves, not in a laboratory filled with computers, not in a university research center, but beside the roaring furnaces of the industrial age, covered in coal dust and machine oil. Elijah McCoy did not just make machines run smoother, he made them smarter, giving them a blueprint for autonomy that would echo through the centuries. He gave them what could be called a mechanical soul, an internal logic that allowed them to function independently and intelligently, and though history may have tried to forget his name, every self-operating machine in the world today carries his legacy in motion, a testament to the power of one man's vision and the tragedy of a world that tried to deny that vision because of the color of his skin.